Routing protocol authentication. Now in the next couple of videos, we'll be discussing about something called routing protocol authentication. So authentication is a method used by the router which is going to authenticate the source of each and every routing update. Let's take an example. I got a router 1. Router 1 is running EIGRP protocol. It can be EIGRP or it can be OSPF or it can be RIP version 2. So by default, what happens is whenever you advertise this interface, this router is going to send a hello message, right? And then the remaining process happens. So after that, they will send the update and then they will send the acknowledgement. Finally, they will exchange the routes and build the routing table. It's something like dynamic process which happens in all the dynamic routing protocols. So what I want to do is I want to ensure that this process should only happen once the authentication is successful. So what I'm going to do is I'm going to configure some password on both the routers, and I want to ensure that they should only send and receive the hello messages, or they should only send and receive any update if the authentication is successful. So it's one kind of security which can apply for the routing protocols to exchange the routes. So the main reason for implementing this authentication is to ensure or to provide some security. Like take an example, by default, if I'm running EIGRP is going to send a hello message on this interface, and also it is going to send on the LAN interface also, because we are going to advertise with a network command. So when it is sending hello messages, probably you can connect any one device, maybe a router or any other device, maybe it can be connected. So when it is sending a hello message, it is going to send on a multicast address. So when it is sending a hello message on that multicast address, probably an attacker may be in the LAN or maybe on the other side. Anyway, mostly the other side of the router will be our router. Maybe attacker in the LAN can connect a router, and then he can simply join this message by running EIGRP here, and then probably he can read the packets, or he can also participate in the routing, and he can read the packets, which we don't want. So we want to ensure that the routing protocol, we want to ensure that they should only send and receive the hello messages, or anyone who is going to join the group must have a password, and that password should match on both the routers. If that matches, then only it says that okay, authentication is successful. Now we can go with the further process like sending and receiving the hello messages, sending and receiving the updates, and all the process will be successful. And in case if there is a mismatch of the password and if the authentication is not successful, then probably you will not be able to send or receive the hello message. Probably you'll receive that, but it's going to be discarded because of authentication failure. Okay, so many routing protocols support this. Most of the new routing protocols like RIP version 2 supports. Even we can do the same thing with EIGRP. Even we can also do this same thing with OSPF as well as BGP. So probably in the next couple of videos, we'll be discussing on how to configure authentication on RIP version 2, because version 1 do not support. And also we'll see how to configure authentication in OSPF and EIGRP protocols. So before we actually get into the practical scenarios where by implementing the protocols, let's try to understand what are the different types of authentication we have. So we have majorly two kinds of authentications. We have something called simple text authentication or simple password authentication, and we have an MD5 authentication process. Now in case of text authentication, it's going to be very simple. Like the router is going to send a packet, so let's say hello packet, and it's also going to send the key. Now once the key is sent, and the neighbor is going to check the key, and it's going to match its own key. So let's say the password, the key is Cisco123, it's going to match on the opposite side also Cisco123. So if the key matches, then it says okay, the authentication is successful. We can go with the further process, the next steps, and we can exchange the routes, we can send and receive hello messages, and the neighbor authentication is successful. But the major drawback with this simple password authentication is the process is not secure, because we are exchanging the key. So when we are exchanging the key, the process is not successful because we are exchanging the password in a clear text. So to overcome that, what we can do is we can also use something called MD5 authentication. Now in case of MD5 authentication, we are not actually exchanging the keys, or key nothing but password. Okay, so instead of that, the router 1 is going to send something called message digest message, something called some algorithm, you can say some value, or we call it as message digest value or hashing value, which is generated based on the key and the key number, whatever we are using. So it's going to send some hash value, or we can say message digest value. And what the neighbor router is going to do is, neighbor router will also generate based on the key and the key password. It's going to generate the same hash value. So once the hash value matches on both the sides, it says that okay, we got a same hash value, which means the key number and key string is matching. So which means we have a successful authentication. Now the advantage we get with the MD5 authentication is it is much more a secure way of exchanging the keys, or secure authentication process when compared with simple authentication. So there are some protocols like EIGRP supports only MD5 authentication, and we have RIP version 2 which supports both, which means it supports simple authentication as well as MD5 authentication, and OSPF also supports both the authentications, and BGP only supports MD5 authentication. Like I have listed some of the protocols which support simple authentication like ISS, OSPF, RIP. They do support simple password authentication as well as they do support MD5 authentication. Like OSPF supports both, RIP version 2 supports both, whereas EIGRP and BGP, these two only supports MD5. Okay, so probably in our next videos we'll be seeing how to implement RIP authentication. Also we'll see EIGRP authentication, and also we'll see how to implement OSPF authentication with practicals.